Hello everyone, my name is Patrick Griffis from the European Space Agency. I'm here to talk about the EO Dashboard Hackathons and specifically a comparative analysis challenge. So in a nutshell, this challenge, a comparative analysis, has a focus on socioeconomic impacts of the pandemic, of the COVID-19 pandemic. The idea is to perform a comparative investigation of this impact between Asia, Europe, and the United States, and to develop and use simple proxies that can be consistently produced across regions and that can also be potentially integrated into a single economic indicator. So the background to this is basically that the COVID pandemic had an impact on all sorts of different parts of the socioeconomic system. So you can imagine the economic demand and production were greatly affected. Other examples include the absence of agricultural labor workforce, which again affected agricultural production. And the lockdown measures, of course, led to changes in social mobility, which again affected transport. And these effects also trickled down to air quality that we might observe in Earth observation data. This impact, of course, varied strongly between different regions, within regions, and also over time. That's kind of the background to this challenge. So the objective of a comparative analysis are to develop 2 to 3 globally applicable proxies that characterize the impact of the pandemic on air quality or on socioeconomic activities. And then to use Earth observation data from at least 2 of the 3 regions to develop these proxies, ensuring that the assessment can be performed in a consistent way across these different regions. You could consider also to use tri-agency Earth observation data, so from the 3 participating agencies, NASA, ESA and JAXA. And these proxies should be, readily producible in whatever region you're looking at. What do we mean with proxies? So you can think of a proxy in this context as a variable derived from Earth observation data that provides one way of quantifying the developments in a certain element of the socioeconomic system over time. In a similar way, we often think of the economy, which is commonly represented by several indicators, some for industrial production, some might be looking at retail trade. And each of these elements looks at a different element of the economic system. In a similar way, you can develop proxies based on Earth observation data. In this example here, you see a time series of synthetic aperture radar data over the parking lot of a car producer. And here the rationale behind it is basically that the more cars are parked on this parking lot, the more industrial output you can have, and the higher the backscatter signal will be over time. So the backscatter here, the time series of backscatter, can be used to characterize the economic activity in this car manufacturing site. You can think of similar proxies to be developed based on Sentinel-5 Tropomi observations of nitrogen dioxide concentrations, which of course are available in the Eurodata Cube environment and other environments. You can also use the social mobility data that we have on the dashboard that characterize different elements of the social mobility, and you can incorporate these into your proxy development. So we also suggest in this challenge that you create strategic sets of areas of interest. So while it is certainly going to be interesting to compare among different regions, so Asia, Europe, and the US, parts of them, it will also be interesting to focus your analysis on certain areas of interest within these regions. And there are some great tools that can help you do that. One of the most commonly used is, of course, the OpenStreetMap, which provides also an API for programmatically selecting these areas of interest. And one great starting point for this is the Overpass web interface, where you can explore in a playful way how to make these areas of interest selections programmatically and then extract the geometries of these features and include them directly into your analysis. A few final potential considerations. So first of all, we have prepared plenty of tutorial materials in form of Jupyter notebooks. So do please take a look at these. They describe most of the things that I just mentioned, how to implement them. Further, you could consider how several proxies that you developed could potentially be integrated into a single integrated indicator that you produce for these different areas. Further, you can consider demonstrating how your proxies and your integrated indicator changes over time or across regions. With that, I wish you the best of luck and enjoy the challenge. Thank you.
Hello from Japan. I am Shiomi from Earth Observation Research Center of Japan Aerospace Exploration Agency. Welcome to Earth Observation Dashboard Hackathon. I appreciate your interest in this hackathon and look forward to seeing the wonderful results. The challenge of this title is a comparative analysis of the pandemic's economic impacts. The COVID-19 pandemic has had different impacts in different regions of the world. We assume these impacts depend on a number of different factors. Your challenge is to perform a comparative analysis of the pandemic's economic impacts. You will assess air quality and air pollution impact, such as greenhouse gas and NO2, for a representative sample of commercial and health facilities in urban areas in the US, Asia, and Europe using the EO dashboard. I will give you an idea to approach this challenge. Use Earth observation data from the 3 regions for the developed proxies, ensuring the same assessment can be performed in US, Europe, and Asia. Can you develop 2 or 3 globally applicable indicators or proxies that characterize the level and changes in socio-economic activities due to COVID-19 in relevant areas such as commercial and health facilities? Can you develop an economic composite indicator with air quality and air pollution indicators that allows you to characterize the level of socio-economic activities in different economic sectors and comparatively across the study regions? You should focus your investigation on selected aspects of the socio-economic system with relevant to pandemic-related impacts such as air quality, public health, and commercial retail. You should demonstrate following points. The first, how can your composite indicator perform in quantifying the economic impact of the pandemic and demonstrating the economic impact with air quality and air pollution indicators? The second, how this changes and evolves over time. And the third, how this differs across the study regions. For example, Sentinel-1 and EROS-2 SAR sensors provide highly routine and consistent backscatter measurements at 3-meter resolution for EROS-2 selected city or 10-meter resolution for both sensors. Variations in backscatter in different local time can be used as a proxy for the number of parked cars in large parking areas. Slowdown and recovery proxy maps for 100 cities in the world utilizing Sentinel-1 and EROS-2 imagery detect changes in human activity associated with COVID-19 closures and slowdown, as well as track changes in human activity as economic activity begins to resume. EO nitride datasets such as those provided by the wheels provided a complementary view as they measure the variations in artificial illumination. On the other hand, because of decreasing economic activity caused by lockdown, we can detect the decrease in anthropogenic activities, equating to the decrease in greenhouse gas CO2 and methane by OCO2 and GOSAT, and pollutants NO2 by tropomi and OMI from power plant, factory, oil and coal mining, and transport. You may use open source maps such as OpenStreetMap to show relevant areas in different categories and create a representative sample of these areas for the study regions. For example, you can extract the 50 largest retail, healthcare, or other sites and their associated parking lots. You may integrate additional data sources to strengthen and validate the proxies or the composite indicator, such as mobility data or statistical datasets. Now enjoy week-long EO Dashboard Hackathon.